Ladies and gentlemen, we are going to discuss statistics. By definition, statistics is a branch of mathematics dealing with data collection, analysis, interpretation, presentation, and organization. So there are several types of statistics, each serving different purposes and providing different insights from data. In data analysis, of course, we are looking at how can we make sense of that data? How can we draw insights? How can we draw lessons? How can we draw conclusions from that data? And so at the end of the day, we are able to present our results and having interpreted the data and of course the results. So at the end, we are able to provide solution to different challenges and make important decisions. So the different categories, we said we have one called descriptive statistics. And this is the category that summarizes and describes the features of a data set. They provide simple summaries and visualizations about a sample and the measures. So these, of course, include what we call measure of central tendency. We also have measure of dispersion. Under measure of central tendency, we have mean, median, and mode. For measure of dispersion, we have range, variance, and standard deviation. Now let's look at the mean. A mean is simply the average of the data points that you have. So if you have x point, you have points represented by x, maybe x1, x2, x3, x4 up to xn. Then you have the number of those individual values being n. If you have each data point having an individual frequency, then we can use this formula of mean to calculate for the mean. So that will be summation of f times x divided by summation of frequency. This is when you have frequency. But if you don't have frequency, you're only going to get the value or values of x, you total them, then divide by their number, and you'll still be able to get the mean. If you have grouped data, obviously you would take this equation or that formula for finding mean. F is the class frequency and x is the mid value. So you'll be having grouped data from, for example, 5 to 10, maybe 10 to 15. So you realize that each of those classes has got its own frequency. And then to get the value of x, it would be the lower class boundary plus the upper class boundary divided by 2, you'll be able to get the mid value. And then the class frequency is always provided. So we are saying the next other point that we are talking about is median. A median is the middle value in data when arranged in ascending or descending order. So for any odd n, if you have the number of values or observations equivalent to n and it is odd, then the position of median is always going to be n plus 1 divided by 2. Now, when you have any grouped data, we said you arrange the data into ascending or descending order, then you'll be able to cancel the first and the last. The next cancel each other, then you get what remains in the middle is going to be your median. If in the middle you remain with the 2, you are going to add them together and divide by 2. So what you will get will be the median of those data points. So if you have grouped data, you are going to use this formula at the lower class boundary of the median class plus the frequency, total frequency divided by 2 minus cumulative frequency before the median class, everything divided by frequency of the median class times the class width of the median class. That is C. So As I've already said, error B is that, C is that, frequency is that, then this is the cumulative frequency before the median class. So if we take an example of such data, 0 to less 5, then less 15, less 30, less 50, and so on and so forth. This is how we are going to do it. You have the number of people, that is the frequency. So they are asking us to calculate the mean. So what we are going to do is to generate our frequency distribution table. Then we have age. So we are saying we have 0 to less 5. So 0 to less 5 and then less 15. So that means it will be 5 less 15. 15 less 30. 30 less 50. So to get the midpoint or the mid value, it will be 0 plus 5 divided by 2, 5 plus 15 divided by 2, 15 plus 30 divided by 2, 30 plus 50 divided by 2, you get 40, up to 70 plus 90 divided by 2, you get 80. Then the frequency you also put and get a column for the product between X and F. Now, here you total your values of frequency, you also total the values of fx. Then another column is going to be for cumulative frequency, CF. So cumulative frequency, how do you generate it? You first write the first value of frequency here for 0 less 5. So is 44. So 44, to get the next value of cumulative frequency, you are going to cumulate them. So you get 81 plus 44. So 81 plus 44, this is going to be 125. 125 plus 105, you'll get 230. Like that, like that. To get this one, you get 47 plus 474, you get 521. If you don't get the value, the last value of cumulative frequency, equivalent to the total frequency of your distribution, then it is going to be wrong. You go back and recheck. You recumulate until you get a similar value here that is equal to 521, or that is equal to the sum of frequency. Then the class boundary, you also generate it in that way for this type of kind of data, because this is grouped, but then they have brought it as 0 less 5 less 15 less 30. So this is how you generate the class boundary. So to get your mean, this is going to be calculated using the formula sum of fx divided by sum of f. So sum of fx is 18762.5. Then you divide it by 521, which is the sum of frequency, and you get 36.012 as your mean. Then the median, we are going to use this formula, and it's going to be error B plus sum of frequency divided by 2 minus cumulative frequency before the median class, everything divided by frequency of the median class times the class width of the median class. So the class width, let's calculate for it. It is going to be 50 minus 30, and that is 20. Then the frequency of the median class. How do we get the median class first of all? So to get the median class is always our first step. So you get your frequency divided by 2. Sum of frequency divided by 2, you will get 260.5. So you go to the cumulative frequency column. You look for a value that is so close to 260.5. So 230 is far away and even less than 260. You will need to go to a value which is at least slightly higher than 260.5. It is the one that will contain that class that you are looking for. So 376 is the one that has that 260.5. So we shall run and go to this other side, actually this side, and we'll be able to get the class width. To get the class boundary. So the class boundary is 30 to 50, and then, to less 50, So you are able to get the class width, and you are also able to get the lower class boundary. So the lower class boundary is 30, that's why we are putting it here. Then the sum of frequency divided by 2 is 260.5 minus the cumulative frequency before the median class. The median class we said is here 376, 30 to less 50. So the cumulative frequency before it is 230. So that's why we are putting 230 here. Divided by 146. 146 is the frequency of the median class. So frequency of the median class, we said the median class is 30 to less 50. So the median class is around there, and that is 146. So multiply by the 20, then you'll have your median 34.178 years. So that is how you can calculate the mean and calculate the median. Of course, that was our major focus given grouped data. So what about mode? So mode is the most common value in the data, and if you have any grouped data, this is most easier, the easiest, actually the easiest to calculate. You just look at a value which is most common. Like here, 7 is the most common, and so 7 becomes our mode. If we have grouped data, this is how we can calculate mode by using this formula. C is the class, this is supposed to be multiplied by C. We are saying this one in brackets, this one, D1 divided by D1 plus D2, we are supposed to multiply it by C. Yes, you are supposed to note that. It's arrow naught plus D1 divided by D1 plus D2 times C. Okay. Now, D1 is the frequency of the model class minus the frequency before it. Then D2 is the frequency of the model class minus frequency after it. So this one, you need to rewrite it very well. It is supposed to be frequency of the model class minus frequency after it, not frequency of the class after minus frequency of the model class. This is wrong. It should be the other way around. Okay. Now, if we have this other one, we are talking about this for grouped data. It means we have a uniform class width. But if we have a non-uniform class width or unequal class width, we are going to use what we call frequency densities. So mode is going to be LB, which is the lower class boundary of the model class, then plus the model frequency density minus the pre-frequency density. So that means the frequency density before it. What about this other one is the model frequency density minus post-frequency density, or the model frequency density minus frequency density after it. The frequency density is frequency divided by class width. Let us look at this example, and then we'll be able to understand better.